Hello everyone. Welcome to the solution of LeetCode problem 113 named path sum 2. In this problem, we are given the root of a binary tree and the integer target sum. Now we have to return all the root to leaf path where the sum of the node value in the path equals to the target sum. And here each path should be written as a list of node values, not the node references. Now here, a root to leaf path is a path starting from the root and ending at any leaf node. And here, a leaf node is a node which has no children. So in the first example, we can see that the root is 5, which has 2 children, 4 and 8. 4 has 1 children, which is 11. 11 has 2 children, 7 and 2. And 8 also has 2 children, 13 and 4. And 4 has 2 children, 5 and 1. So here, the target sum is 22. So we can see that in this path 5, 4, 11, 2 and 5, 8, 4 and 5, the summation of all of them is 22. So we have to return both of them. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Here, basically in this problem, we will apply the depth first search mechanism. So basically, depth first search is a graph traversal algorithm where we can traverse the graph or tree and calculate the answer. So here, our target is 22. So we can see that in this path, 5, 4, 11, 2 and 5, 8, 4 and 5, the summation of both of the path is 22. So here, we have to return these two paths. But the problem is, how can we do it? Now let's see how the DFS algorithm basically works here. In the DFS algorithm, we will start from the root node 5. Now, if we take 5 as the consideration, now what is the target sum we have to make after this? The target sum we have to make will be 17, which will be 22 minus 5. Now from 5, let's say our call is in this 4. So if we consider these 4 as one of the value into our path, what is the target sum we have to make? It will be 17 minus 4, which will be 13. Now, let's say our call in this node 11. So here, if we consider 11 in one of our possible path, so what is the target sum till now? It will be 13 minus 11, 2. Now, from this 11, let's say our call is in this node, which is 2. Now here, let's assume that 2 is a leaf node because it does not have any of the left or right children. And our target value is 2 and its current value is 2. That means if we take these 2 as the path, our target value will become 0. That means we have found a path from root to leaf where the summation of all of the elements value is equal to 22. So this is one possible path. Similarly, we can go in the right side. Let's say from root our call into this node 8. So it will become 17 minus 8, which is 9. And from this 8, the call will be in this 4. And the target will become 9 minus 4, which is 5. Now from this 5, the call will be in this node 5 and the target will become 0. And as the 5 is a leaf node, so we can say that this path has all of the node where the summation of all of the elements is 22. Now I hope you understood the concept. So here the one more observation is that it can be possible that if any of the node we have considered till now does not belong to the path, suppose this node 13 or this node 1. So in this kind of cases, we have to pop back or remove them into the call stack. I hope you understood how the DFS function works here. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named pathSum, which has a root and a target sum as a parameter. Now we are taking one directional vector and one two directional vector to store the answer. Now we are recursively calling the DFS function into the root with the target sum. And here in the DFS function, if the root is null, we have to simply return. And here, suppose we are taking the current root as the consideration of the path. So we are inserting the value into the temp. And here, if root does not have any of the left or right children, that means it is a leaf. And root value is equal to target sum. We have to insert the temporary vector VC to the resultant vector VC. Now, we have to recursively call the DFS function into the left subtree and into the right subtree with the value of target sum minus root of value. And it can be possible that our current value is not available in the desired path, or we can say that our current root is not the member of the any of the root to leaf path. So this kind of cases, we have to simply remove them or remove the current root from the temporary vector. Finally, we have to return the VC. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.